welcome back to the new lecture number 6, Federal Board Chemistry, chapter number 9, class 10. Now, yesterday we have discussed about the equilibrium constants and their definition. Equilibrium constant and their definition with explanation and some examples. Now we are going to explain that the equilibrium constant expression, how we can write the equilibrium constant expression for the reactions and their units. So we have a question about this topic, that write the equilibrium expression for each reaction and also find out their units. Now for each reaction, first of all, we will write the equilibrium constant expression and then we will find out their units. Now coming toward the first one, number A, which is hydrogen in the form of gas, NH2 in the form of gas, which is a reversible reaction which give to HI, hydrogen iodide. Now as you know that the equilibrium expression, but this one is Kc is equal to Hi. This one too will be raised to the power. This too will be raised to the power to the concentration of the product divided by reactants. The reactant will be written in denominator. That is the concentration of H2 multiplied by concentration of I2. Now in terms of the units, we will write this expression as Kc is equal to mole per decimeter cube. This will be written in the power. This expression will be shown in the power. So we will write that the product square divided by the reactant in the form of multiplications. Reactant will be in the form of multiplication, which will be done in the denominator. So further, Kc, we will take Kc in mole per decimeter cube. We have already discussed in many lectures that Kc will be taken in mole per decimeter cube. Kc will be taken in mole per decimeter cube. Many times we have repeated in many lectures. Now the Kc will be, that is mole per decimeter cube, mole per. We write this power. Twice time we write this. That is, this will be written twice. Mole per decimeter cube multiplied by mole per decimeter cube divided by the same which lie in the denominator. So it will be cancelled with one another, and then Kc have no any units. Kc have no unit for this one reaction. In this case, Kc have no any unit because all the units in the numerator and the denominator equally cancel with each other. Coming toward the reaction number B, you understand? Coming to the reaction number B, which is the 2NO plus O2, which give 2NO2. So in the equilibrium constant expression, this coefficient, the value of this one mean this coefficient will be raised to the power of concentration of the product. This product, so this value will be in power. So divided by this, in the coefficient we have 2. In the coefficient we have 2. So this 2 will be written as in the power of concentration of reactant, and this Rc multiplied by oxygen. This will be written, the reactant always written in denominator, and this will be written in numerator. So this is square. So we will take the concentration in mole per decimeter cube. The square will be on the same place. So the square will be on the same place in the reactant and also in the product. So this will be cancelled with one another, and it has plus 1 power when we are coming toward the above. So it will become as mole per That is, the Ks is equal to decimeter cube mole per mole, decimeter cube per mole, decimeter cube per mole. So this all about the equilibrium constant expression. It is very easy. First we have already write this in the form of equilibrium constant expression. Then we have found their units. Same for this one reaction. If you have any question regarding this one topic, you can ask in the comment box. Thank you.